In this video, we are going to do problems on fundamental theorem of calculus. So what is fundamental theorem of calculus, which I've already explained in my previous video. So you can go through my previous video. The link of that video I can put in the description box. So now let's start with the fundamental theorem of calculus questions. So it has basically two parts. One is a part 1. So part 1 is basically d by dx of integration a to x ft dt equal to f of x. So in the part 1 we are going to solve basically three types of problems. So type 1 is basically direct questions. So let's say example I give you, say integration, say 2 to x, say e raised to t square dt and d by dx of that. So this is direct questions. And type 2 basically applying the chain rule. So example I'm giving you d by dx integration say 1 to root x tan x ln t dt. And the type 3 is basically when both the limits of integration are variables. Like suppose you have x to 2x cos t square dt. So they are going to deal with three types of problem, type 1, type 2 and type 3 on the part 1 of fundamental theorem of calculus. Now similarly in part 2 of the fundamental theorem of calculus, this says say integration from a to b f of x dx equal to uppercase f b minus uppercase f a. So where f of x is the antiderivative of fx. So that is f dash x is equal to f of x. So the example of this type of question will come say 2 to 3 say x square dx. So we are going to solve different types of problems now. So now I am going to solve type 1 problem. Say the first question is, say find d by dx integration from say 2 to x e raised to t square dt. Now let say f of t equal to e raised to t square and a is equal to 2. So this can be rewritten as d by dx from a to x f of t dt. So by fundamental theorem the answer will be f of x. So here you can write, because from ftc we know d by dx a to x f of t dt equal to f of x. Okay, now this answer is equal to, so when f of t is e raised to t square, so f of x will be e raised to x square. So this also you can write down here, because f of t equal to e raised to t square, so therefore f of x is equal to e raised to x square. Now let us solve one more question on type 2. Say find the derivative d by dx of integration from 3 to x t raised to root t dt. So here select a is equal to 3 and f of t is equal to t raised to root t. So this above question can be written rewritten as a to x f of t dt. So the answer will be f of x by fundamental theorem of calculus by FTC. So f of t is e raised to root t, so f of x will be x raised to root x. Now let us solve one more question of this type. So find the derivative of, so integration x to negative 3 root over 1 plus sine t dt. So now here I can change the limit. So I can add d by dx minus 3 to x root over 1 plus sine t dt. So when I change the limits, I have to put a negative sign here. So this negative sign I can take it out, d by dx negative 3 to x root over 1 plus sine t dt. Now here, so let a equal to negative 3 and f of t equal to root over 1 plus sine t. So therefore this will be negative d by dx. So a to x f of t dt. So this is equal to negative f of x. Now negative f of x, when f of t is root over 1 plus sine t, so this will be root over 1 plus sine x. So now we are going to solve type 2 of fundamental theorem of calculus. So the 5-2 is using the chain rule. So using chain rule. The question is d by dx integration 8 to x square ln x 1 over 1 plus tq dt. So here you see the upper limit is not x. Upper limit is x square ln x but not x. So we can't apply, so therefore we can't apply FTC directly. FTC directly. So what you do here, so let u equal to x square ln x and say y equal to integration say 8 to x square ln x 1 over 1 plus tq dt. So this can be written as integration from 8 to u 1 over 1 plus tq dt. Now here you can see the u is a function of x and the y is a function of u. So therefore y is a composite function, is a composite function. So therefore dy dx equal to dy du into du dx. This is my chain rule. So now let's find dy du. So dy du equal to dy du integration 8 to u 1 over 1 plus tq dt. Now here, so let a is equal to 8 and f of t equal to 1 over 1 plus t cube. So this can be written d by du integration from a to u f of t and dt. So this I can write as by fundamental theorem of calculus f of u. So f of t is 1 by 1 plus t cube. So this is 1 by 1 plus u cube. Now you know u equal to x square ln x. So du dx can be found out using the product rule. So x square into 1 by x plus ln x into 2x. So this is x plus 2x ln x. So if I take x common from here, so this is 1 plus 2 ln x. Now you combine these two to get dy dx. So dy dx is dy du into du dx. So dy du is 1 over 1 plus u cube, and this is x bracket 1 plus 2 ln x. So now you see you have taken u as x square ln x to 1 plus x square ln x whole cube into x into 1 plus 2 ln x. So this you can write finally as 1 over 1 plus x raised to x ln x whole raised to 3 into x into 1 plus 2 ln x. So this is the answer for this. So now I am going to solve one more question of type 2. So d by dx of integration 1 to root x tan x ln t dt. So here the upper limit is not x. This is root x tan x. So you need to apply chain rule. You can't apply FTC directly here. So what you do here is let u equal to root x tan x and y equal to integration root x tan x ln t dt. So this can be as 1 to u ln t dt. Now here you see u is a function of x and y is a function of u. So therefore y is a composite function. So dy dx will be here dy du into du dx. This is your bi-chain rule. Now how do you find out dy du? So dy du equal to d by du integration 1 to u ln t dt. So here, so let a equal to 1 and f of t equal to ln t. So this I can write in here d by du integration a to u f of t and dt. So by fundamental theorem of calculus, this is equal to f of u by f t c. Now f of t is ln t, so f of u will be equal to how much? Ln u, because f of t is equal to ln t. So therefore f of u equal to ln u. Now you have taken is how much? Root x tan x. So du dx will be equal to, you would apply product rule here. So first into derivative of second, that is x square x, plus second into the derivative of first, that is 1 over 2 root x. So this I can simplify as 2 root x is the LCM here. So this is 2x sec square x plus tan x. So now you can find out dy dx. So that is equal to dy du into du dx. Now dy du is ln u and du dx you got how much? 2x sec square x plus tan x upon 2 root x. So ln u is root x tan x into 2x x square x plus tan x whole upon 2 root x. So now I'm going to solve one more question of type 2. So d by dx integration 0 to x cos t dt whole cube. So what you do here, so let u equal to integration 0 to t cos t dt. So du dx will be how much? D by dx 0 to x cos t dt. So this is equal to cos of x by FTC, fundamental theorem of calculus. Now you need to find out d by dx u cube. So you apply the chain rule here, d by du u cube into du dx. So this is equal to 3u square into du dx. Now you see 3 u square will be how much? Integration 0 to x cos t dt का whole square and du dx you got as cos x. Now this is equal to 3. What is the integration of cos t? That is sin t. And then this is 0 to x whole cube into cos x. So this is 3 bracket sin x minus sin 0 whole cube cos x 3 sin cube x into cos x. So now I'm going to solve type 3 question where both the limits are of variables. Say x to x cos t square dt. So how can you solve this? So this is d by dx. So I can write x to 0 cos square dt plus 0 to 2x cos t square dt. This I can separate him d by dx cos t square dt plus d by dx 0 to 2x cos t square dt. So we'll do the question part by part. So this is d by dx cos t square dt. Now this is d by dx. If I change the limit, so 0 to x cos t square dt, then it will be negative sign. So negative I can take it out. Now this is 0 2x cos t square dt. So by fundamental theorem of calculus, I can write this is minus cos x square. So by FTC. So this is the first part of this. Second part is, second part, the upper limit is your 2x. It is not x. So you have to apply chain rule here. Chain rule you have to apply to solve the question. What you do here? So let u equal to 2x and let say y equal to integration 0 to 2x cos t square dt. So this we can write u cos t square. So if I want to find dy du, it will be how much? Dy du 0 to u cos u square cos t square dt. So this will be how much by fundamental theorem? Cos of u square. So by FTC. Now du dx is equal to 2 because u is equal to 2x. Now dy dx equal to dy du into du dx. So dy du got cos of u square and du got x2. So cos u square means 2x whole square into 2. So now you'll add both cos x square plus 2 cos 2x whole square. So this I can put the plus sign here. So this is the final answer for this question. So now we are going to solve questions based on FTC2, Fundamental Theorem of Calculus, Part 2. So it says integration a to b f of x dx equal to uppercase f b minus uppercase f a. Provided fx has to be a continuous function, is continuous function in the closed interval a comma b, and f dash x should be equal to f of x. That is f of x, capital F of x is the antiderivative, is antiderivative of small fx. So this is all about the FTC2. Now you are going to solve the question. Say integration from 1 to 3 x cube dx. So now here you see here f of x equal to x cube, a equal to 1 and b equal to 3. Now here f of x, that is x cube, is continuous in the closed interval 1 comma 3. So FTC can be applied here. So therefore 1 to 3 x cube dx equal to f of b minus f of a. This is by fundamental theorem of calculus. So what is the antiderivative of x cube? That is x raised to 4 by 4. So now here, so therefore here I can write a sentence, capital F of x equal to x raised to 4 by 4. So f of b will be f of 3. So f of 3 minus f of 1. So f of 3 will be 3 raised to 4 by 4 minus 1 raised to 4 by 4. That is 81 by 4 minus 1 by 4. So 80 by 4, the answer is equal to 20. Now let's solve one more question based on this. Say integration 0 to 5 1 over x minus 3 whole square dx. So here f of x is equal to 1 by x minus 3 whole square, a equal to 0 and b is equal to 5. So if I plot the graph for this function, so at x is equal to 3 is an asymptote here. This graph will be like this and it will be like this. So this is equal to x is equal to 3. Now you can see from the graph also f of x is not continuous on close interval 0 4 5 because it is discontinuous at x is equal to 3. So therefore you can write here ftc does not hold and so it cannot be applied. It cannot be applied. So now let's say one more question on this. Question number 3. Say 0 to 1 1 over x minus 3 whole square into dx. So here you can say f of x equal to 1 over x minus 3 whole square, a equal to 0 and b equal to 1. So f of x is continuous here, continuous in the close interval 0 1, because x minus 3 it is discontinuous at x equal to 3 but not in the interval 0 to 1, and so ftc can be applied. So ftc can be applied. So an antiderivative of f is f of x, that is equal to negative 1 over x minus 3. So therefore this answer will be equal to f of b minus f of a by FTC, fundamental theorem of calculus. So that is f of 1 minus f of 0. So f of x is negative 1 by x minus 3. So 1 by 1 minus 3 minus 1 by 0 minus 3. So 1 by 2 minus 1 by 3. So the answer is 1 by 6.